Hey everyone, Mr. Skelton here. We are back at it, lesson 5, unit 6, and today we're going to be focusing on some conversions. We're going to be converting between degrees and radians. We learned about the difference between degrees and radians a little bit with our unit circle. And so again, degrees and radians are the same, they're doing the same thing. They're accomplishing the same idea. It's just two different forms of measurement, okay? And then the third thing we're going to be doing is we're going to be finding arc lengths, which you actually did in geo. So this is a geo review, all right, and we'll talk about it at the very end. But again, we're going to be going from degrees and turning them into radians, but we're also going to be starting with radians and turning them into degrees. So 1, 2, 3 total things that we're going to try to accomplish in this unit. All right, let's jump right into it here. So you'll find that there are various ways to do this. I'm going to stay consistent throughout this lesson because I want to stay with something that's mathematically sound, but you may find a little shortcut here and there that may work for you, and that's totally fine, all right? So basically what we're going to do is, in this first section here, we're going to be changing the following from degrees into radians. And what we want to always try to do, what I'm always going to try to do, is to create a proportion. Now, what is a proportion? Right? What's a proportion? A proportion is two equal ratios. In other words, not rations, ratios. Okay? Two equal ratios. And so when we want to change 180 degrees into radians, again, you could look at this and know the answer based on the unit circle. That's one way to do it. The other way to do it is to create a proportion. Now, a proportion would be something like this, pi over 180. Now the reason I put pi over 180 is because pi is equal to 180 on the unit circle, okay? And so this would be radians on top, and this would be degrees on the bottom. So when I create my proportion, here's my degrees, 180. So I'm going to put that on the bottom, and I want to turn it into x, or what we don't know, radians. So radians over degrees equals radians over degrees. And then how do you solve proportions? We always cross multiply. Okay, so we get 180x equals 180 pi. And what are we always solving for? We're always solving for x, so I would divide by 180 here. And my 180s would both cancel out, and I would be left with x equaling pi. And that makes sense because we know that pi is 180. From your unit circle that we just did a little bit ago, right? We did the unit circle. We start at 0, and you go halfway around. That's 180 degrees, which is pi radians. Okay? So I'm going to do number 2, and then I'll have you do number 3. So again, I always start with pi over 180. Some students will go 2 pi over 360. I don't like to do that because it's just bigger numbers, but you could easily do this because 2 pi is 360 degrees. But I just usually stick with pi over 180. Okay? You could also go 180 over pi as long as you're consistent. I go radians on top, degree on the bottom, equals 130 degrees or 135 degrees, x radians. Got to stay consistent. Radians over degrees, cross multiply. 180x equals 135 pi. Take your calculator out because you remember you're solving for x always. So that would be x equals. And then we want to try to keep these as fractions. We don't want to make these decimals. So we go 135. Fraction bar, sometimes this works, 180. And it'll reduce it for you, and you just get 3/4. Sorry, let me do that again so you can see. Use the fraction bar. So 135. This is your fraction button. It says A, B divided by C, and then over 180, and then it reduces your fraction for you, so 3/4 pi. So 3/4 pi. Don't forget your pi, because remember radians are always within pi. Okay, try number 3 on your own, hit pause, and then see how you did. All right, so I always go pi over 180, radians over degrees, cross multiply, 330 pi equals 180x, divide by 180, divide by 180. So here we're going to have 330, fraction bar 180. Okay, we're going to get 1 and 5/6. That's a little glary there. 1 and 5/6, 1 and 5/6. Now, usually when we do radians, we want to keep it as an improper fraction. So do you remember how to change a mixed number to an improper fraction? You multiply, right? 6 times 1, and then you add 5. So 6 times 1 is 6. 6 plus 5 is 11, and you keep the same denominator, so this would be 11/6 pi. Okay? Now some of you may be thinking, okay, what would the shortcut be here? What is happening every single time in these proportions to get our radians? We're just doing what? We're basically dividing by 180 and slapping a pi onto it, right? If you look at 135 divided by 180, slap a pi onto it. 330 divided by 180, slap a pi onto it. That's the shortcut, but I stick with the proportion. Next page, moving along, okay? Doing the same exact thing. I'm not even going to do all of these because it's the exact same thing. I definitely want to do number 4 because you'll notice there's a negative sign there. Don't let that scare you. It's still pi over 180 equals, we're going from the degree into radians, so that would be x over negative 120. So it's 180x, negative 120 pi. We're solving. I keep doing this. I keep putting pi instead of x. 180 times x is 180x. Negative 120 times pi is negative 120 pi. We're solving for x, so we divide by 180. And we get x equals, now you're going to keep the negative here, so 120, fraction bar 180, 2/3, so negative 2/3 pi. So negative 2/3 pi. Okay? If you want to try the rest of these, you can. Obviously 500 degrees is pretty big, but again, it's the same song and dance. It's pi over 180 equals x radians over 510 degrees. 180x equals 510 pi, divide by 180, divide by 180, and x equals, again, for sake of consistency, 510 fraction bar 180. It equals, you get 2 and 5/6, 2 and 5/6, but we want to make that an improper fraction. 6 times 2 is 12. 12 plus 5 is 17/6, so this would be 17/6 pi, because we want to leave it as an improper fraction. I'm not even going to do these because we just did 6 of them. I think we did 4 on the front, maybe we did 3. We did 3 on the front and 2 on the back. It's the same song and dance. So let's keep moving. Now, here we're going to do converting from radians to degrees. Good news is you do the exact same thing. Again, you'll see a shortcut here, but let's just stick with it. Pi over 180 equals, remember it's radians on top, degrees on the bottom, and you could flip-flop that as long as you're consistent. And then now I have radians given to me, and I want to figure out what the degrees are. Radians over degrees, radians over degrees. We're still cross-multiplying. So I got 180 pi divided by 3 equaling pi times x. Now, 180 divided by 3 should give me 60, so I basically have 60 pi equaling pi times x. How do you solve for x? You divide by pi. So your pi's will cancel out there, your pi's will cancel out there, and you get x equals 60 degrees. 60 degrees is pi thirds. And again, you may know this just from your unit circle. Like if you know that pi thirds is basically, here's how I think of it. I look at pi, I know that pi is equal to 180 degrees. So if pi is getting cut in half, basically what they're saying is, hey, what's 1/3 of pi? Well, 1/3 of pi basically means 1/3 of 180, and 1/3 of 180 is 60 degrees. So you can think of it that way too. So yeah, you can use a proportion, but if you put some thought into it a little bit, that's really good. If you have a conceptual understanding of what's happening, you're good. You're taking they're asking you what's 2/5 of pi. So again, if you want to set up the proportion, go ahead. So 2/5 pi, you get x times pi equals, basically, if you take 180 and times it by 2, 180 times 2/5, all right, you get 72, so that's 72 pi, and then just divide by pi, you're going to get x equals 72. Again, for me, when I look at this, I just think, okay, it's 2/5 of pi. In other words, I'm taking pi and timesing it by 2/5. So basically what I'm taking is, if pi is equal to 180, I'm taking 2/5 of 180. So you could also just go 180 times it by 2/5, and you get 72. You get the same exact thing, okay? I'm going to do 10 and 11 the way I would do it, which is I'm taking 5/8 of pi and turning it into degrees, which is basically 5/8 of 180. So 180 times by 5/8, that's going to give me 112.5 degrees. Again, you could go pi over 180 times it by 5 pi eighths, and then go from there over x, cross multiply. Okay? 13 tenths pi, which means you're taking 13 tenths of pi. Or in other words, if you're converting it to degrees, it'd be 13 tenths of 180. So I would go 13 tenths, let's see my calculator there, times that by 180, 234. Okay? Again, you could set up the proportion if you wanted to. Okay, last thing, and that's really, look, what we just did is the bulk of the assignment, changing from radians to degrees and degrees to radians. Now this is the geometry review that we talked about in the beginning. This is our geo review. We want to find arc length, and I will give you the equation for arc length because it's something you probably don't remember, but here's how arc length works. Arc length, if you want to find the length of an arc, what they're talking about, first of all, is this distance right here. When I say arc length, I want to actually know what is the distance from A to C. That's what arc length is. What is the actual distance from point A to point C on that circle? So here's how you do it. It's kind of common sense. What you want to do is you want to take the measure of the arc, divide it by 360 because you just want to find this piece. So you'll find the measure of the arc. Now the measure of the arc is the same thing as its central angle. You may remember from geometry this is called a central angle right here because it's from the center. And so the measure of AC is 45 degrees. We want to create a fraction or a ratio because we just want a piece of this arc. This whole arc is the whole thing. We just want this little sliver. So that's why it's divided by 360 because we just want a section of it. We times that by, well, think about it. What is this? What's the distance around a circle? That's circumference, right? That's circumference. So we just want a fraction, right here, fraction of the circumference, 2 pi r. And that's how you find arc length. Again, this is a formula. Yeah, you can memorize it, but if you just put a little bit of thought into it and understand the concept, I think you're going to be better off in the future. So let's do this problem. What is the measure of arc AC? Well, its central angle is 45, so that means the measure of the arc is 45. So it's 45 over 360. That's how we get a fraction of this entire circle. And we're timesing it by circumference because, again, circumference is length around the outside of a circle, and that radius is 3.5. Okay? And we are going to actually, sometimes they'll ask you to leave your answer in terms of pi, but for this I think we're just going to do exact answers. So we're going to go 45 divided by 360, which is 0.125, and we're going to times that by 2 times pi times 3.5, and you can do this a bunch of different ways, right? 2 times 3.5 is 7, so really it's 0.125 times pi times 7, and you can do it that way, times pi times 7 equals, and I get 2.748, okay? And that would be the actual length of that, that arc. Now, the only thing that can be a little confusing, and you're going to see this on your homework, and I want to point it out to you. Let's say, I'm just going to redraw this as best I can. Instead of 45 degrees, what's 45 degrees in radians? So let's think about that. We just spent a bunch of time doing pi over 180 times, I'm asking you to convert 45 degrees into radians, so 45 x radians, so that's 45 pi equals 180x divided by 180, right? So you take your calculator out, 45 divided by, oops, we'll go fraction bar, 45 fraction bar 180, it equals, we get 1/4, that's 1/4 pi, and that should make sense, right? 45 is 1/4 of 180 degrees. The reason I say that to you is on your homework, you're not just going to see degrees. In fact, I think you're going to see a lot of this. They're going to put that there and say this is AC and this is 3.5. So instead of degrees, they give it to you in radians. What can you do? Well, you can do the same exact thing. What I would do is convert this into degrees first. If they give you the problem like this, convert pi force into 45 degrees and then rock and roll from there. So I don't want you to be caught off guard when you do your assignment and you see that they're giving it to you in radians instead of degrees. You can convert back and forth. Okay? Look forward to seeing you in class. If you got questions, let me know.